Hello everyone, and welcome to Lab 1 of our Strands Agent series. I'm excited to guide you through your first steps with this powerful open source SDK. My name is Laura Salinas, and I'll be helping you navigate this course alongside my friend Elizabeth and some other folks who you'll see a little later on. Let's start by covering what you'll accomplish by the end of this lab. You'll understand what agents and agentic workflows are. You'll understand the Strands Agents SDK, install the Strands Agents framework, create your first agent, configure an agent with custom prompts, and enhance your agent by adding tools. Now, Strands Agents takes a model-driven approach to building AI agents. And what I find most impressive is that you can have a fully functioning agent up and running in fewer than 10 lines of code. This isn't just a prototyping tool either. Teams at AWS have already used Strands in production, including for the building and shipping of the QCLI product for agentic coding experiences. Now, compared with frameworks that require developers to define complex workflows for their agents, Strands simplifies agent development by embracing the capabilities of these state-of-the-art models to plan, chain thoughts, call tools, and reflect. With Strands, you can simply define a prompt and a list of tools in your code to build the agent and then test it locally and deploy it to the cloud when you're ready. Like the two strands of DNA, Strands connects the two core pieces of the agent together, the model and the tools. Strands plans the agent's next step and executes using the advanced reasoning capabilities of the underlying models. For more complex agent use cases, you can customize your agent's behavior in Strands. For example, you can specify how tools are selected, customize how context is managed, choose where session and memory are stored, and build multi-agent applications. Strands can run anywhere and can support any model with reasoning and tool use capabilities. That includes models from Anthropic, Ollama, Meta, Amazon Bedrock, OpenAI, and other providers through LightLLM. Now, let's dive in and see how quickly we can get started with Strands. First, we'll set up our development environment. I'll be using VS Code here for this walkthrough, but feel free to use your IDE of choice. You'll find that in the code repository attached to this course, we have several Python files that are pre-created for you to help you follow along. Before we start looking into some of those files, it's recommended to create a Python virtual environment for this project to help maintain any packages and dependencies. You can do that with the following Python commands in your terminal. Now, I've already done this in my terminal, so I can just show that to you here. You'll see that the Python environment is created, the virtual environment, and you can go ahead and activate that now by using this command. And you'll see that I'm already in that virtual environment, so I won't be doing that, but you'll find that it should show up here in your terminal when it's activated. Okay, now we'll install the Strands packages. There are two packages that we'll want to install. The first one you'll do with the pip command, pip install Strands Agents, and then the following will be the same command, but Strands Agents tools. So go ahead and run both of those and make sure that the packages complete successfully. Now, the first package gives us the core functionality, while the second provides built-in tools that Strands has, which will help extend our agent's capabilities. One important note here, Strands uses Amazon Bedrock as the default model provider with the Claude 3.7 Sonnet model. Make sure that you have the AWS credentials configured and model access enabled. This will happen if you use it by default. You'll need the AWS CLI set up, and you can check our documentation links in the course resources to make sure you have that set up. We won't be covering that here. We'll be covering how to change model providers in Lab 2, so stick around to see how we do that. Okay, now that the admin tasks are complete, we can go ahead and create our first agent. Open up the basic use Python file from that repository. Now you'll see that in this file, there are only really 3 main lines of code. There's several other comments here to help folks kind of understand what's happening in the file, but there's 3 main lines of code. We first import the agent class from the SDK. That's what's happening here in line 3. You can think of this as the brain that will coordinate between the models, the tools, and your prompts. Next, in line 8, you create an instance of the agent with default settings. Again, the default settings are to use Amazon Bedrock as a provider. And then finally, in line 12, we call the agent like a function and pass a string with our prompt. Behind the scenes, the agent is sending this prompt to the large language model you've selected and then returns a response. And that's it. In just 3 lines of code, we have a working agent. Let's go ahead and run it. And we'll see that the model provides a response here. You can see that Strands is working and provides a comprehensive response about our prompt, what is agentic AI? The agent automatically handles the connection to the model provider and returns a natural language response. This demonstrates the power of Strands. With minimal code, you can get a fully functional agent without having to write complex orchestration logic. Now, let's create something a little more interesting. I want to build a specialized agent that helps new pet parents find the right dog breed for their lifestyle. For this example, navigate to the system prompt use file in the repository. I'll go ahead and clear my terminal here. In this file, we see our agent definition now also includes the system prompt parameter, as you can see in line 10. This is how we can tell our agent what we expect its behavior and expertise to be. More specifically, in the system prompt, you can define the agent's role, its knowledge domain, and guidelines for behavior. You can kind of think of this as the space where the agent's personality and training is defined. Now, when Strands puts all these pieces together, it's performing an agentic loop where it combines a system prompt, our user, and any conversational history and passes that context to the selected model to generate a response. In this case, I'll go ahead and run this specialized agent so we can see what's happening. Perfect. We can see the agent now provides some expert level advice tailored to the specific lifestyle requirements in the user query. Again, just to revisit that, the query was, which dog should I adopt as a first-time owner if I have an office job, I like to hike on weekends, and I don't know much about training. And just like that, we've created a domain-specific agent with Strands. We can see the response here from Strands. So again, it takes my user query. It understands that as an agent, it's a dog breed expert, and it's going to help pet parents decide what breed meets their lifestyles. And I've given it some boundaries as to how it should answer those questions, the number of recommendations it should provide at a time. And then down here, the response, we can see it's recommended a golden retriever, a Brittany, and what was that last one? A Labrador retriever. So I'll go ahead and clear my terminal here. Now let's take our agent to the next level by adding tools. Tools transform a basic conversational agent into a truly useful assistant that can interact with the world. Let's enhance our dog expert agent with web search capabilities. First, let's open up the HTTP tool use Python file from the included repository. Now here you'll see there are some changes from the last time we saw this file when we used it earlier with the system prompt. First, there's a new import. So we can see from Strands tools, we're importing the HTTP request tool. Now Strands comes with 20 plus pre-built tools in the Strands Agents tools package that we installed earlier. And this HTTP request tool allows agents to make HTTP requests to external APIs. And we'll see how that's helpful a little bit later on. These tools follow the Model Context Protocol, or MCP standard for interoperability. Next, we can see we're using a tools parameter. So we're using tools equals and then passing in the HTTP request tool. Here, what we're doing is we're passing a list of tool functions to the agent constructor. In this case, we're only using one tool, but you can use many different tools here. Strands automatically registers these tools and makes them available to the language model. The model receives a description of each tool's capabilities and parameters. Now, let's break down this tool use. When you provide a tool to an agent, here's basically what's happening. The tool is getting registered, so Strand analyzes each tool's function signature and docstring. There's some schema generation, so there's a JSON schema that's describing the tool's purpose and the parameters. In terms of model awareness, the underlying language model receives this schema, and that's how it understands when and how to use the tools. And then finally, Strands takes care of this automatic orchestration. So the model will then decide when to use that tool based on our user query. Next, we can also see that we've updated our query to include a web search. So my query now has two parts. The second part of this query is to search Wikipedia for the top 5 most popular dog breeds over the last 5 years. Now, we talked a little bit earlier about the agentic loop, and I want to talk a little bit about the enhanced agentic loop now. By providing Strands with tools, the loop becomes much more sophisticated. We can see that a user provides a query that might need external data. The model analyzes the query and determines if the tools are needed. If the tools are needed, the model calls the appropriate tool or tools with the right parameters. Strands then executes the tool and provides the results back to the model. The model incorporates the tool results into its final response. And finally, a user receives a comprehensive answer combining both the model's underlying knowledge and any real-time data that was provided by the tools. Let's run this enhanced agent now. So we are back in our HTTP tool use file, and I'll go ahead and run this now. Okay, did you catch that? So we see that Strands, as we review the response, it's breaking down both of my questions in parts. So for the first question, it's giving me the same answer as it did before with some of the breeds that I should be looking at as a first-time pet parent. And now for my second question, it understands that it has to use a tool. So it says, okay, for your second question, I've got to search Wikipedia. I have to use the HTTP request tool, and I go ahead and do that. So it goes ahead and says, okay, I've got the information from Wikipedia, and these are the top 5 most popular breeds in the United States. Okay, so Strands automatically determined that to answer the second question, it needed to use the HTTP request tool. The agent intelligently chooses when and how to use the available tools based on the context of our conversation. We had no manual orchestration given we didn't write any logic for when to use the tools. This demonstrates the model-driven approach we spoke of earlier. The language model itself orchestrates when and how to use tools, rather than having to write complex workflow logic. Now, let's take a look at some troubleshooting and best practices. Let me share some important tips from real-world usage. First, for error handling, you might encounter throttling limits depending on which tools and depending on which models you're using Strands with. Now, I encountered some errors with the HTTP request tool using too many tokens and causing my application to time out. I was using Amazon Bedrock in this case, so you'll see a snippet of the error message that I was getting here. Again, if you're getting errors like this, you may consider switching to a different model and experimenting with other model providers. Keep in mind the following best practices. Start simple and add complexity gradually. Test your system prompts with different queries. If you are using AWS Services, understand your service quotas when using tools, and be prepared to switch models if you do encounter issues like this. Now let's go over some next steps. First of all, congratulations. In this lab, you have successfully installed the Strands agent, created your first basic agent, built a specialized agent with custom prompts, and enhanced your agent with web search capabilities via tool use. Now here are some key takeaways from Lab 1. Strands makes agent creation incredibly straightforward. You can build functioning agents in under 10 lines of code. System prompts are powerful for domain specialization. And finally, tools extend agents beyond simple text generation. In our next lab, we'll be diving deeper into using other model providers and understanding how that changes our Python files and our use of Strands agents. Now keep experimenting with different system prompts and tools. The possibilities are endless. And don't forget to check out the course resources for additional documentation and troubleshooting guides. Thank you again for joining me, and I'll see you in the next lab. Hello and welcome back. My name is Laura Salinas, and in this lesson, we'll be learning how to connect your Strands agents to various large language model providers. In our previous lab, we learned what Strands agents are, how to set up the SDK, how to create our first agent, how to customize that agent's behavior using the system prompt parameter, and we started looking at introducing tool use with the Strands built-in tools package. Now in this lab, we'll be covering what the model provider abstraction is and why it matters. We'll also be connecting to Anthropic Claude's models directly via their API. We'll take a look at setting up LightLLM integration with Strands. We'll look at how to configure other models within the Amazon Bedrock model provider platform. And we'll take a look at some best practices for choosing the right provider. Now, by the end of this lesson, you'll understand how to leverage multiple LLM providers in your Strands applications and make informed decisions about which models to use for different scenarios. Okay, so the model provider abstraction is Strands' way of creating a unified interface across different LLM providers. You can kind of think of it as a universal translator that lets your agent code remain almost identical regardless of whether you're using Anthropic, OpenAI, Amazon Bedrock, or any other supported provider. Now, here's what makes this so powerful. Let's take a look at this example from the Strands GitHub. We see the same agent configured with different providers. Notice how the agent interaction remains the same, only the model provider changes. This abstraction gives you incredible flexibility to experiment with different models, optimize for cost or performance, and even switch providers based on specific use cases. Let's review the key benefits that this model provider abstraction provides. First, provider flexibility. I mentioned this earlier, but you can switch between different cloud and local models as you see fit. There's a consistent API, so the same code works across different providers. All you're doing is changing up that API key. There's easy experimentation. You can test different models without having to rewrite complex logic. And production adaptability. You can choose optimal providers for different environments, for different use cases, and depending on what you want your agents to be doing. Okay, let's move on to our first LLM provider integration. We'll be connecting to Anthropic's Claude models directly via their API. This gives you access to the latest Claude models, often before they're available through other providers. Let's move over to some code. In order to give Strands the ability to switch model providers from its default, we have to install the Anthropic dependency. You can do that with the following command. Now, I've already done this in my system, but go ahead and wait for that to finish up. For this example, you can follow along in the provided Python file in the attached course repository, anthropicmodelprovider.py. Okay, so we've opened up that file, and here is the code. Now let's walk through some differences from what we've seen in the previous files in Lab 1. First, let's take a look at client args, which is one of the main differences here. This dictionary configures the underlying Anthropic client, so the API key is required, and you can get this from your Anthropic console, so make sure to have that handy before you start this lab. Now in the params, this additional model parameters, you can include things like temperature for controlling response randomness. Here you can see that I've set the temperature to 0.3. The lower values make your responses a bit more deterministic. The higher values give the model some more room to be creative. Now in this example, we run through a simple example using Anthropic directly. So again, I've passed in my API key via an environment variable. And in this case, I'm actually going to be doing some tool use. So to recap, we used some tools in Lab 1. For Lab 1, we used the HTTP request tool, and we were making a call out to the internet for a Wikipedia search. Now in this case, I'm actually going to be doing something a little bit more fun. So I've gone ahead and imported the generate image and current time tools. Now again, these are tools that are pre-built with Anthropic when you download the Anthropic Strands tools package. And again, if you're not familiar with what that is, we've downloaded that in Lab 1, so go ahead and check that out. But now moving on for this case, just to show how we're using Anthropic together with Strands and with tools still. So all of that still works. In this case, again, down here, we're creating an agent. We're using the model configuration that we've set up here with Anthropic. And we're going to be exposing the generate image and current time tools to our agent. In this case, I'm giving the agent this query, generate an image of a husky surfing on a surfboard in the Philippines, and also share the current time after you generate the image. So let's go ahead and do that now. I'll run this, and we'll see what kind of image we generate here. Now again, behind the scenes, Strands is making a connection directly to Anthropic with the Claude 3.7 model with an API key that I have for Anthropic. It'll give me a generated image using that tool. So we can see here, it understands in my natural language query that I've asked it to create an image. So it has to go out and use a generate image tool. It goes ahead and does that. And then it also goes ahead and answers my second question, which was give me the current time. And the current time is going to pull from the current time tool available to Anthropic. And here we go. So we've got a Husky image and the current time is like we see here in UTC. And then let's take that Husky image. Okay, pretty neat. Now I'm not sure if this is telling me it's the Philippines, but it's definitely a Husky on a surfboard. So that's pretty cool. So again, in this example, we've reviewed setting up Anthropic as a model provider, understanding that you have to pass in your API key directly, and we can continue to use tools like we did in Lab 1 when Amazon Bedrock was our model provider. The same thing is happening here. One small caveat, because I'm using some of the built-in tools with Strands, the generate image tool is using some AWS services on the back end. So if you're getting any errors when trying to run this file, it might be because you don't have your AWS CLI set up in your terminal. On the back end, I have that already set up, so it's using my AWS account to actually go ahead and try to use that tool. So just make sure you have that set up. There are some tools within the Strands package, the pre-built tools, that on the back end use AWS. So make sure to check out what's going on with each package. You can take a look at that by going to the tools and the example tools package in the Strands documentation. Every tool gives the GitHub repo for what it's using. So in our case, when we use the generate image, we can see here that it's using Amazon Bedrock on the back end. Or you can try to use a tool that doesn't necessarily use AWS services on the back end and just call a different API directly. I want to take us back to a file from Lab 1 where we were working with that pet breed agent. Now, if you remember in Lab 1, and I'll go ahead and open that here, when we were using this agent, we had given it a system prompt and then passed in 2 queries. So again, it was which dog I should adopt, and then search Wikipedia for the top 5 breeds. In this case, we were still using the default settings for Strands. So on the back end, this was actually using Amazon Bedrock. And in this case, I was using Claude Sonnet 3.5. Now let's take the same file and just plug in Anthropic. So if you go ahead and head to the Anthropic pet breed agent Python file under Lab 2, you'll find the exact same file, except what we've changed is now the model is being called in directly from Anthropic, and we can use one of the latest models, Claude Sonnet 4. Now I'll put them here side by side so you can see the differences, but in our first file with Amazon Bedrock, we weren't defining any model because we were using the default agent class, so we weren't changing anything about that. Now we're defining the model with Anthropic and specifically calling out that we want to use Sonnet 4. And that's really the main difference. The rest of the file, as you can see here, is the exact same. I'm using the same system prompt. I'm passing in the same tool, HTTP request, and then the query remains the same. So the same things are happening in each file. The only difference is I'm now using Anthropic directly versus using it through Amazon Bedrock. And just to show that this function is the same, we'll go ahead and run this file. So again, the only difference here in running this file versus the one in Lab 1 is that now I'm going directly through Anthropic with an API key that I own, and it's just doing the same thing. So it's going to go ahead and use that HTTP request tool to answer my question, and then goes in and answers my first question about which are the best dog breeds for lifestyles. And this is streaming in real time, so we're getting answers in our terminal here. Great. And so that describes both of the different files that we have here. I want to introduce some providers that Strands supports, which can unlock additional, smaller, and use case specific models not commonly found with the larger providers like Amazon Bedrock or OpenAI. Now, LightLLM is a unified interface for various LLM providers that allows you to interact with hundreds of models. With LightLLM, you can find models from providers like Databricks, Grok, 11 Labs, and others. Similar to Anthropic, support for Strands for LightLLM comes first via the installation of a dependency. Let's take a look at what that looks like. From our terminal, we can set up to use Strands with LightLLM with the following command. Now let's take a look here at the Strands documentation for how we would use LightLLM. Like we saw in the Anthropic example, Strands uses LightLLM in a similar fashion. You pass in your API keys for the models you want to use, and then define the model configuration and any parameters you want to specify. So in this example, we're using 3.7 and some parameters that are being passed in here. Again, you'll see that we've imported the LightLLM dependency here, and you're ready to keep going forward. Now let's talk about another model that I want to highlight here. If your use case requires local development, I encourage you to explore Ollama for Strands as well. For local development, Ollama is particularly useful for the following reasons. First, it's free to use. It runs entirely offline. It's great for experimentation, and there's no API costs during development. One caveat here is because you're running these models locally with Ollama, you're going to want hardware that can support running these models locally. So make sure that you look into the Ollama documentation before you go ahead and do that.
You can install the Ollama dependency using the following command.
Okay, now I mentioned in the last video that Amazon Bedrock is actually Strands' default provider. Like we saw with Anthropic and LightLLM earlier, you're able to use these models directly, but you'll have to manage the API keys yourself. Whereas with Bedrock, you give access to multiple leading foundation models through a single managed API. Now, as a bonus, we talked about, again, Anthropic and LightLLM integrations in this video, but let's say you did want to use Amazon Bedrock. We saw already the defaults in Lab 1, so that'll look a little bit like this. As of Strands 1.0 version, it's actually using Claude for Sonnet in the backend by default, so this will be basically a default configuration with Bedrock. Now for more control, you can specify the exact model and parameters. Just make sure to import the package for Bedrock model in your application in order to do this. And I'll show that here. Again, these files are included in the repository, so you'll see them here. But this is the Bedrock detailed config file, which just shows how to do some of this configuration that I talked about earlier. So again, you're importing that Bedrock model in order to do this, and then you can go ahead and really customize the type of model that you're using with Amazon Bedrock. Now, I wanted to just break down what some of these different model parameters do. So in this case, the model ID, pretty straightforward. This identifies the specific foundation model. The format here includes a region, the provider, and the model version. You can find this on the Amazon Bedrock documentation for the specific syntax. Now, temperature here measures or controls creativity. I mentioned this a little bit earlier, but the range is from 0.0 to about 1.0. So the lower on that scale, the more deterministic and accurate results the LLM will provide. On the higher end, 1.0 and above, you're giving it a lot of creativity. So that's usually better for something like image generation or content where you want the model to be less deterministic. This third value here for top P is basically a nucleus sampling parameter, which affects how token selection and diversity is kind of happening behind the scenes. So controls token selection. And then finally here for streaming equals true, when we have this enabled, and you've noticed this in our examples here, the responses come back from Strands and from Amazon Bedrock progressively rather than all at once. So we're seeing it in a streaming effect. So the answers that the LLM is providing are kind of flowing in through my terminal versus kind of waiting and kind of batching for all of the response and then printing it to the console. And that's basically what's happening here with a more detailed configuration for Amazon Bedrock. Now, we talked earlier about what it means to use Amazon Bedrock with Strands. Amazon Bedrock uses the Boto 3 for AWS authentication, so you will need AWS credentials configured either through the environment variables, so like the ones you see kind of listed here on the screen, or through AWS CLI configuration, which is my preferred way of using it, or through IAM roles, which we do recommend for production. But again, you will need to have that installed and set up in your system before you actually use Strands with Amazon Bedrock. Otherwise, you're going to run into some permission issues. And like I mentioned in Lab 1, you will need to request model access through Amazon Bedrock in the console before actually using any of these models. And that just takes care of accepting the end user licensing agreements, or EULAs. If you're not familiar with what those are, you can check that out in the Bedrock documentation. But that's just some practical setup if you were wanting to use Amazon Bedrock with other models. Otherwise, again, you can use Anthropic directly, LightLLM, OpenAI, a variety of different models that we've covered here and more, which you can find in the Strands documentation. Now, you might be thinking, okay, great, I can use all of these different providers, but how do I choose the right one? Here's a practical guide. For Amazon Bedrock, you can consider if you're already in the AWS ecosystem, it might make sense to do something like that with Amazon Bedrock. If you need enterprise security and compliance, if you want to access multiple model providers through one API rather than managing a bunch of different APIs, and if you need managed scaling and reliability. For Anthropic, you can use them directly if you want perhaps the latest Claude models first. If you need specialized Claude features, or if you're building applications that specifically are tailored for Claude's capabilities. And then finally here, you can use Ollama for local development and testing, privacy-sensitive applications, offline requirements, and some cost-free experimentation. Again, the caveat here is your local hardware, your laptop, your CPU, has to be able to run these models on its own since you're not going out to the cloud to host them. Now, some other additional factors to consider when choosing a provider: cost, of course. Local models are free, but like I mentioned, do require you to have the hardware. Cloud models have a usage-based pricing, so you want to make sure you know what you're spending as you use it. For latency, of course, local models will eliminate that network overhead. Capabilities, different models excel at different tasks, so you'll want to make sure you know which model to use for what kind of use case. And then in terms of reliability, managed services, of course, offer some SLAs and uptime guarantees that you might not have moving from one model provider to another. Okay, congratulations, you've completed Lab 2. Now today we've covered how Strands' model provider abstraction gives you incredible flexibility in choosing and switching between LLM providers. You learned how to configure agents with Amazon Bedrock, Anthropic, LightLLM, and understanding when to use each different provider. In our next lesson, we'll explore more of Strands' built-in tools to understand how we can continue extending the capabilities beyond what underlying LLMs are capable of. Again, thank you so much for watching. Don't forget to check out the Strands documentation at strandsagents.com and check out the GitHub repository for more examples. Thanks again for watching, and I'll see you in the next lab. Hello, and welcome to this lesson on connecting your Strands agent to AWS Services. My name is Laura, and today we'll explore how to give your AI agents the ability to interact with AWS services like Amazon S3 and Amazon DynamoDB using Strands' built-in useAWS tool. Now, by the end of this video, you'll understand how to set up secure AWS connections for your agents, use the useAWS tool to interact with these services, and build practical examples of agents that use AWS services. Now let's dive in. First, we'll walk through some setting up of the AWS credentials and permissions. These are required to use this particular tool because it's connecting to an AWS account that will now use AWS services. So again, before we can connect our agent to AWS, we need to set up these proper authentication and permissions. This is a critical step for Strands' ability to correctly authenticate to use AWS APIs as you interact with the tool. Here's a quick overview of what you'll want to set up. There's the AWS credentials, so your agent needs AWS credentials to authenticate. There's IAM permissions, and again here you'll only want to be granting the minimum permissions needed. And then there's some environment variables for development locally on our system, so we want to store those credentials securely and make sure we're not hard coding any API keys when we're developing locally. Now, for development, there's a variety of different ways in which you can configure your credentials for CLI setup. You can use AWS Configure on your terminal, like you see here, or you can set environment variables directly by doing these commands. So export AWS access key, export your AWS secret access key, and then exporting your AWS default region. One thing to make sure that you're following, again, there is a link here included in the deck that goes along with the course. It will basically take you to the documentation to set up your AWS CLI. So I recommend you double check that you have all of this set up correctly before you get started with this Lab 3. And again, the link is included in the source repository as well as the deck that goes alongside with this course. There's a variety of different ways in which you can set up your credentials. So just make sure that you are picking the right one for the type of AWS account that you have and the permissions that you have. Some folks might prefer to do short-term credentials. Others may have an existing IAM Identity Center set up for their AWS accounts. So just double check your settings here and then meet us back in the lab when you're ready. Okay, now let's say you've got your credentials all set up, you've configured your AWS CLI. To run the examples in this lab, we're also going to want to make sure that the permissions that you have on the AWS user that you're using for this demo has these permissions. So I'll pause here and just kind of take a look a little bit more closely at what these permissions are. So for S3, the demonstration in the code that we'll see in a little bit here is going to need the S3 list bucket permission, as well as the S3 list all my buckets permission. And then for DynamoDB, you're going to want to be able to do a describe table, a query, and then a scan. So these are the permissions that an AWS user would need to have in order to correctly run our lab. Now, as always, want to make sure that you're following the principles of least privilege, which means you're granting only the permissions that your agent actually needs to do the tasks. So that's why I bring these up. Don't recommend that you have a user that has admin permissions for everything. Make sure that you're locking down your user. Okay, so next we're going to walk through understanding what tool we're going to be using today as part of the Strands tools package. Again, this is a built-in tool. We covered some of these tools in Lab 2. In this particular lab, we're only going to be covering one tool and how that works to plug in your Strands agent to AWS Services. So we'll move over here to the Strands GitHub and we'll scroll down here to the useAWS tool. Again, this is the tool that's going to help us interact with AWS Services. And when you click into this, you can see the entire Python file that basically is giving Strands an explanation of how to use this tool and what it's capable of doing. Okay, so here's a snippet of the tool that we're going to be referencing today. And I wanted to highlight some of the specific parts of this tool that some folks may not be familiar with. So for the service name, this one's pretty self-explanatory, but this is corresponding to the Boto3 service name. So S3, DynamoDB, Lambda, EC2, etc. The second item here is the operation name. So this is the specific API operation that you want to call. List buckets, describe table, etc. The parameters here is a dictionary of parameters specific to that operation. So that will vary depending on which API you're using. The region, again, self-explanatory, is the AWS region where the operation should be performed. And then a label is a human-readable description that helps our agent understand what this operation does. In this example here, it's a list all S3 buckets as the label. So these are some of the basics of understanding what this particular tool is doing and how Strands is understanding the aspects that we're giving to this tool that we're passing in so that it knows what to do with it. Now this tool essentially wraps Boto3 operations. So any operation you can perform with Boto3, you can perform through this useAWS tool. And what this means is this gives you access to the entire AWS API service area. And we'll take a look at what some of those examples are over here in the code. Now for this example, we'll first be looking at listing some S3 buckets. So in the course repository, you'll find Lab 3 has just one file in it. So go ahead and navigate to that. And it's called AWS tools use.py. And we'll take a look at starting with a simple example. So listing all S3 buckets in an AWS account. Now with natural language, I can ask Strands to list all my S3 buckets, and it will know that it has to use the tool that we've provided to answer this query. So just stepping back for a bit and taking a look at the code, I'll zoom in here for some readability. So this is very similar to the code that we've already reviewed in Lab 2 and Lab 1, so I won't cover what we're doing at the top here. Again, this file is pretty heavily commented so that you can follow along if this is your first time taking a look at the file. But we're doing the same things as we did in the past. So we are loading our environment variables. In this case, I'm loading in an Anthropic API key because I'm using Strands with Claude Sonnet 4 directly. So I'm loading in an API key that I have for Anthropic. And then I'm just creating an instance of the Strands agent, telling it to use the model that I've configured up here. And I'm letting it know that it can use or has access to a tool called useAWS, and that it should figure out when to use that depending on what I'm asking. So the first query that we have here is list the S3 buckets in my account. So let's go ahead and run this and see what Strands comes up with. Now, behind the scenes, the agent is first understanding that I want to list all my S3 buckets. It's going ahead and selecting the useAWS tool that I've provided to Strands, and it's calling the tool with all the appropriate parameters. So it knows to say its S3 service name, it knows that the operation name is list buckets. So we can take a look here at all my S3 buckets, and of course I've had to blur some of them out for privacy, but in general, you can get the hint here, right? It's listing all my S3 buckets, and I'm able to just kind of run a quick audit on them. And that's it. With just this simple setup, I've been able to have Strands generate for me my entire working list of S3 buckets. So pretty cool. Okay, for our second example, we're using the same file, but now let's take a look at a more complex query. We're going to be asking Strands to query from a pre-existing DynamoDB table. Now, there's some assumptions that I've made here, so let's review what's going on behind the scenes. In this scenario, I've already created a DynamoDB table called user profiles in my AWS account. Now, it has a partition key of user ID, which is a string, a sort key of day, which is another string, and it has some attributes like name, email, and status, which are all strings. Next, in our Python code, we're creating a natural language query. So we'll go back to the code for a second here, and I'll comment out the S3 query, and we'll uncomment the Dynamo query. So what's happening here is I'm saying to Strands, I want the agent to first understand that it has to go into DynamoDB and identify a table called user profiles. It should be able to recognize all the items that I want for a specific user ID. So I've passed in here the user 123, and you can see that here. And then I wanted to select the proper operation for DynamoDB. So it should be able to query the table and then list the items and then return them to me in the proper format. Now, DynamoDB typically returns data in a specific format as a JSON file, so it would look something like this, but this isn't very readable for me, so I want to specifically call out to Strands that I want it to return the results to me in a way that is a bit more readable, and you can see that in the query here. I say, please show me the results in a readable format, so I don't want to see JSON. And we expect that the agent will automatically parse this type of return from the API call and then present it to me in a way that I can easily interpret it. So let's see if that works when I run the file. Okay, so first we can see that the agent is going in and querying a table, and it returns a response of the corresponding items in that table for the user 123. So again, just to highlight here what's come up, let me zoom in a little bit here. Strands has gone in. It understands that I've said I want to query the table called user profiles. I want to get all the items for a user called user 123, and this is in the US West 2 region. Strands is saying back to us, okay, I've got to use the useAWS tool. Let me perform that query on the back end, and let me return the results in a way that's readable. So it's not returning to me a JSON kind of string. It's printing out these items in a way that makes sense to me. Okay, so great. We see here that there's one item for user 123. We can see the corresponding attributes. So there's a name, an email, a status, and a timestamp. I think I said day earlier, but I think I must have made it a timestamp field when I created the table, not day. What if we wanted to ask the agent to perform a slightly more complex table operation? We'll take a look at that now. Okay, so if you're following along on the provided file, you can go ahead and comment out that previous query and uncomment the following one. So in this next one, I'm saying to the agent, I want you to find all the users in this table that have an attribute of a status equal to active. So we saw earlier in the previous response that this user Bob Jones is active in this table. And so we know that that's an existing attribute for this table. Okay, so let's go ahead and run this new request by the agent and we'll see what happens. So again, don't forget to save that file because we've changed the query there. Okay, so now we see the new query here, and we see that the agent returns a list of all the users that have that status of active and shows their corresponding names and email addresses. It even gives me a nice summary here of what it's retrieved. So this is pretty neat, right? This is just a taste of what you can do with Strands agents using natural language and expanding their capabilities with tools. Again, for the useAWS tool we demonstrated here, any operations you can perform with Boto 3, you can perform through this tool as well. So your agent essentially has the entire AWS API service area to play with. Just to recap, this file here has all of those queries in the same file, so you can just comment them in and out as you want to play around with it. The first one is that S3 list buckets one. The second one is to query the table for items under a particular user. And then the final one is to query the table and find all of the users that have a status of active. Okay, that's it for our coding samples in this lab. Let's review some best practices before we wrap up. Now, in terms of resource cleanup, one other idea that you can do with Strands agents is you can consider, of course, resource lifecycle management. So making sure that anything you're spinning up, that you're shutting down if you no longer need it. You can also try running this by the agent to clean up the resources that it creates. Again, because it has the Boto 3 capabilities underneath the hood, it's able to do a lot of the deletes as well for resources. Now, in terms of cost considerations, definitely make sure to monitor your API calls. In our case, for this example, each tool use does incur AWS API charges because we are, running a query, we are listing, we are doing those API queries on the back end. So definitely, if you're interested, set up some CloudWatch alarms to monitor for any unexpected usage, and consider implementing some rate limiting for your production agents. Just want to wrap up and say congratulations, you've now completed Lab 3. In this lab, just to recap, what we've learned, we've set up secure AWS connections for Strands agents. You've used the useAWS tool that Strands provides to interact with 2 different AWS services. And you've seen how we built some practical examples for Amazon S3 and Amazon DynamoDB, listing our buckets and running a simple query and a slightly more complex one on the DynamoDB table. Now remember, Strands excels when you embrace this model-driven approach, so let the agent figure out the workflow and focus on providing clear prompts and the right tools. Thank you again for watching this introduction to Strands agents. Now, in the next labs, you'll be introduced to my friend Elizabeth, who will guide you through using Strands with MCP, Langfuse, and also teach you how to build a RAG agent. Stay tuned for that, and happy building.
Welcome to Lab 4 of our Strands Agent course. So far, you have created basic agents and connect them with different model providers. Now, you will empower this agent with tools that will allow them to interact with external systems, access data, and manipulate their environment. And you are going to learn how to use the Model Context Protocol MCP as one of those tools. So let's get started. Tools are the primary mechanism for extended agent capabilities, enable them to perform actions beyond simple text generation. Agents know the tools when we create them, making tools available for use through the agent's lifecycle. Once the tool is loaded, the agent can use these tools in response to user requests. We can see which tools are available in our agent with the agent tools name. And we can know the tool description and input parameters with the agent tools config. Tools can also be loaded to the agent by passing a file path to our agents during initialization. And Strands offer built-in example tools to get started quicker. Strands also offer Python tools or custom tools. You can build your own Python tools using the Strands SDK's tools interface. You use the function decorator tools that can be placed anywhere in your code base and imported into your agent list of tools. For example, here we have a function that transforms from Fahrenheit to Celsius, and we use the tool decorator to define this function. And last, we have the Model Context Protocol, MCP, that is an open protocol that standardizes way to expose and consume tools across different systems. This approach is great for creating reusable tools collection that can be shared across multiple agents or applications. You can create your own MCP server to extend agents' capabilities. Here is a code example of a calculator MCP server. In this example, we use FastMCP to create an MCP server. And FastMCP is a Python framework that simplifies building MCP servers and clients. To help you better understand MCP, let's talk about its architecture. MCP architecture consists of three key components working together. We have the MCP client integrated into the Strands Agent framework. It handles all protocol communication. Then we have the MCP server, an independent service that hosts and manages tools, exposing them through the standardized API. And inside the MCP server, we have the MCP tools, the actual functionalities your agents can use for simple calculations to complex business operations. The MCP servers can be local on your computer or can be accessible on external MCP on the internet. Strands Agent also includes built-in support for connecting to MCP servers and using their tools. First, we have the standard AO for command line tools and local processes that implement MCP tools. This code right here is an example to access a remote server. You can create custom tools with Python, save the code in a Python file, and access it by placing the path to the folder here in the code. But you can also run custom tools in other programming languages. But you have to remember that you must change the command to execute the application, because in this example, useAWS is only for Python file. Then we have the streamable HTTP. The server operates as an independent process that can handle multiple client connections. These transports use HTTP, POST, and GET requests. We have the server send events, SSE, for HTTP-based MCP servers that use server send event transport. And finally, we have custom transport with MCP client. This is for advanced use case that you can implement a custom transport mechanism by using the underlying MCP client class directly. And of course, you can connect to multiple MCP servers simultaneously and combine their tools. Now, let's switch to the notebook. In this notebook here, we will start by building a weather system that uses the HTTP request built-in tool. First, we need to install the libraries. Right here, we have all the libraries that we need in the requirements file. Once we install all the libraries, you need to put your API key. I already did that. Then, for this function, we are going to use the Strands agent to be able to create agents with few lines using Strand. We are going to use Strands agent tools where all the Strand built-in tools are, and we are going to use the Strand agents Anthropic because I am going to use Anthropic as the model provider. We are going to use the HTTP request tools that handles GET, POST authentication, JSON, and error handle. And my agent is going to interact with virtually any REST API. This tool connects Strands agent with external web service and APIs. bringing conversational interaction with data source. So we create this application with this prompt. You are a weather assistant with HTTP capability because our agent need to know the capabilities. And the capabilities are make HTTP requests for the National Weather Service API, this one here, process and display weather forecast data, provide weather information for location in the United States. Always explain the weather condition clearly and provide context for the forecast. Then we start the model provider as Anthropic. We create the agent with HTTP capability, and this line here is the new, because we add a tools and we refer the HTTP request as a tool. So let's run this. Perfect, without error. And let's try this agent. When I ask, what's the weather like in Seattle? The agent automatically makes the necessary API calls and provides me a forecast that I can understand. Now, let's try the same agent, but this time with a custom tool, a Python tool. So we are going to add a new tool that is capable to convert Fahrenheit to Celsius. So this is a simple tool right here. We define the tool with the tools decorator because we import the tools for the Strands Agent framework. We use the same prompt, but this time we add this line here. Use Fahrenheit to Celsius to convert temperatures between Fahrenheit and Celsius. Then we add the new tools here with the HTTP request, so the agent can access to this new tool. Then we try this. With this command here, we can know the tool's name. So we have the HTTP request and the Fahrenheit to Celsius tools. Then we can ask again, but this time, please give me the answer in degrees Celsius. So the agent first is going to request the information for the weather, and then the agent is going to convert the temperature for Fahrenheit to Celsius. And that's all. We receive the information in Celsius. Now, let's build a new application using the Model Context Protocol as a tool. So here, we are going to create a calculator application. We are going to have a calculator agent, and we have the MCP Server calculator tools. The code is already placed here in MCP calculator Python file here. Let me explain you the code. First, we need to start the Anthropic model because that's the model that we are going to use. And remember that you have to put right here your API key. Then we are going to start the calculator server using this function right here. And we are going to use the fast MCP. Remember the Python framework that helps us to create better MCP servers and clients. Then we start to create the tools using the MCP tools decorator. So here we have the addition tools, the subtraction tools, the multiplication tools, and the division tools. Each tool have a clear description so the model can understand what each tool can use. And then we run the server with the streamable HTTP transport, and we use the default port. So then we create the main function. For the main function, we start the MCP server using the trading thread, and we with the target start calculator server. that is right here, the MCP server. So we create the HTTP client because we need a client to who is the one who is going to do the communication with the MCP server. Remember that. And we create a prompt, and the prompt here is: you are a helpful calculator assistant that can perform basic arithmetic operation. You have access to the following calculator tools: the additional, the subtract, multiplication, and divide tool. We create the tools using the MCP server, just right here. And then we need to create the agent who is going to use these tools. So similar that we did before to create the weather assistant, we create the agent. So we put the model provider, we add the system prompt, and we add the tools. So here, for the agent, doesn't matter if the tools is an MCP server, is a custom tool, or is a built-in tool from Strands Agents. And we activate the calculator. So let's run this code. I'm going to open a new terminal here in my VS Code, and I run this code right here. So you just be aware that we are in the same folder that the MCP calculator application is. So we run this, and okay, agent ready, type exit to quit, but we are going to use the calculator. So 4 plus 4, 4. So here the agent show me all the things that it do behind the scenes, and we get the response. Thank you for joining me in the lab 4. In the next lab, we will explore agent-to-agent communication, A2A, where multiple specialized agents work together to solve complex problems. Welcome to Lab 5 of our Getting Started with Strands Agent course. Today, we are exploring agent-to-agent communication, or A2A. But at the end of the session, you will understand A2A architecture and implement multi-agent system. Let's dive in. What is A2A? A2A is an open standard that defines how AI agents discover, communicate, and delegate tasks to each other. A2A protocol support enables several powerful use cases. You have multi-agent workflow, chain multiple specialized agents together. We have agent marketplace to discover and use agents from different providers, cross-platform integration to connect Strands agents with other A2A compatible systems, and we have distributed AI system to build scalable and distributed agent architectures. It's important to understand how A2A relates to MCP. MCP connects agents to tools, APIs, and resources with structured input and output. Think of it as how agents access their capabilities. And A2A enables dynamic communication between different agents as peers. And it's how agents collaborate, delegate, and manage shared tasks. They are complementary. MCP gives agents their tools, and A2A enables collaboration. Let's understand the key components of A2A architecture. First, we have the primary agent, who starts communication and delegates tasks. It's like the manager. Then we have the secondary agent, or agents that receive tasks and provide response, the specialists. And we have the A2A protocol that handles protocol details from seamless communication between the agents. Now let's build an A2A application. In this Jupyter notebook, we will do a walkthrough of selected code blocks that have been used to build the Strands A2A inter-agent application. based on the sample agent IA demo repository to create A2A agents. You can see this repository, click here, and here you are going to find a lot of examples in A2A agent application. Let's return to our example where we will explore a three-tier architecture with a human resource agents that communicate with employee agents, and this employee agent is going to communicate with a MCP server, and the MCP server is going to provide access to the employee data. First, we need some data for our agent to work with. So for that, we are going to create a simple module that generates random employee data with a skill. This is the code, and you can see the module right here. Inside this folder, this is the employee data, and this is the code that we use. Next, we will implement an MCP server that exposes tools to access the employee data. Remember just how we did in the lab 4. Here we have the sample code, and the code is right here, the MCP server code. We are going to use fast MCP to create the server. Then we create the tools. We have the MCP tools decorator. Do you remember just what we did in the lab 4? Here we are going to expose two main tools. We have the get skill to return all possible skills that employee may have. We have the get employee with a skill to return employee that have a special skill. Now we create the employee agent which connect the MCP server and expose its capability to a A2A server. This is the sample code, but let's see the code. The employee agent. So the employee agent is going to act as a bridge between the human resource agent and the MCP server, and is going to provide more intelligent interface to the raw data. It's configured with a system pro. This system pro right here, you must abbreviate employee first name and list all their skill. This is to influence in how this agent is going to respond, the format. And then we create the A2A service. So for that, we use the employee agent that we just create here, and we use the URL that the employee agent and the port for the employee agent that we have just right here. And finally, we create the human resource agent, which is going to provide a user-facing API and communicate with the employee agent. The human resource agents use A2A client to provider to discover and communicate with the employee agent. This one here. The stream response back to the user. And we use get and post to create a health, and we create a post application that we are going to use to ask the agent. Now, let's run this application. So we come back to the Jupyter Notebook. We go to the running the example part. So here, you can run this application with each component in separate in the option 1, but you can use the option 2 where you can run the MCP server, employee agent, and the human resource agent in parallel using only one command. So I'm going to use the option 2 because it's only one command and it's easier. Before to start, remember to set up your API keys. To run the code, I go to New Terminal. I list the folder because we need to be in the Lat 5 folder. Yes, we are there. I already export my API keys, so I don't have to do that again. First, I need to install the required packets, so I do that. Copy the pip install our requirements. So I install all the library that I'm going to need. Then we go to the option 2 here, and we run the run A2A system Python file. When all the services are started, I can start to ask questions to my human resource agent. So for that, I'm going to copy and paste this, and I'm going to ask about the lead employees that have a skill related to AI programming. For that, I'm going to open a new new terminal, paste it in the new terminal. So when I run this command, this question, the human resource agent will receive the question, recognize that it needs information about employees with AI programming, and delegate this task to the employee agent. So here first we have the I'll retrieve the employee who have the machine learning skill and abbreviate their first name as requested. Let me get that information for you. So then this agent is going to use the second tool, get employee with skills. So the employees are Martinez, are Garcia, Williams, Johns, Miller, and more Johns. And then is the agent thing. I will retrieve the employees who have the Python skill and abbreviate their first name are requested. Let me get that information for you. So again, the employee get the employee with a skill. When the human resource agent get all the information that it needs to answer the question, it answer the question, and this employee have a skill in machine learning and or Python, which are technologies used in AI programming. The combination of this skill makes them well suited for AI development work. So the agent understands that for have a skill in AI programming, the person needs to know machine learning and Python. Now that we finished the coding part, let's review some best practice. First, we need to have clear agent's role to define a specific responsibility. For example, the human resource agent handles user interaction and the employee agent have the specialization in data. We need to have effective delegation to ensure coordinator know when and how to delegate tasks. We need to have context preservation to maintain relevant context when passing information between agents. We need to have a robust error handle to handle cases where agents are unavailable or return errors. We need to have optimized communication to minimize agent-to-agent calls to reduce latency and cost. And last, we need monitor performance to track your agent network to identify bottlenecks. Now, you have mastered A2A communication with Strands. In the next lab, we will explore evaluating Strands agent using Langfuse and Ragas to measure and improve agent performance. Thank you for joining me in Lab 5. See you. Welcome to Lab 6, the last one of Getting Started with Strands Agent course. Building agents is only half the battle. Once deployed, how do you know if your agent is working correctly? How do you debug when things go wrong? And how do you measure and improve performance over time? This lab addresses the critical gap between building agents and maintaining them in production. While many developers focus on creating functional agents, few implement proper observability and evaluation, leading to black box systems that are difficult to debug, improve, or trust in production environments. When we build agents, we need to see what's happening inside them and measure the performance. That's exactly what we learned today. By the end of this session, you will understand observability with Langfuse, evaluation with Ragas, and how to build a complete restaurant recommendation agent with this capability. So let's dive in. Let's understand what observability and evaluation actually means. Integer agents allow you to see all the process, tool usage, and decision making behind the scenes, essential for debugging and understanding agent behavior. Evaluation measure if your agent is doing a good job using a specific metric instead of guesswork. Provides concrete data to track improvements and ensure quality standards. In the Strands Agent SDK, observability includes metrics to performance and resource usage number, trace to detail execution path records, logs to operation and event text records, and evaluation to performance measurement methods. Strands integrates with OpenTelemetry, making it compatible with existing observability tools. Before we dive into the code, let me explain you what we are going to build. We will build a restaurant recommendation agent with observability and evaluation capabilities. How this agent recommendation works. A user asks a question about restaurant or agent research the vector database for relevant information. Then the agent generates a response based on the research results, and we trace this entire process with Langfuse, and we're going to evaluate the quality of the response using Ragas metrics. Let's start building the system step by step. I'm going to switch to the Jupyter notebook. First, we need to install the required packets. Using this install our requirements. In this file, we install Langchain that help us build application with LLM. We use Langfuse to provide observability for our agents, Raga to help us evaluate our agent performance. We are going to use DynamoDB as a vector database for storing and searching vector embeddings, docs to text to convert Word documents to text, and last and more important, we are going to use a Strands Agent or framework for building agents. Then we need to create a vector database to store our restaurant information using the Chroma vector store library for Langchain. First, we need to import the necessary libraries for document loading. Then we need to load the doc file. So we are going first to create this function for that. And then we load all the restaurant data files. The restaurant data files is in the restaurant data folder, just right here. And each document have information about each restaurant and the menu that they serve. Then we need to split each document into chunks, because when we split large document into smaller chunks, is to make a search more effective. So when we do that, we need to specify a chunk size and ensure overlap. So we run this, and we need to set up the embedding. So when we create a vector database, this database stores text as numerical vector, the embeddings that represent the meaning of the text, allowing us to search for similar meaning rather than just exact word match. So we perform a mathematical search. So let's create the embedding. We are going to use the Amazon Bedrock embedding with the Amazon Titan embedding text model. We create the model object, and finally we create the vector database. So we create the vector database, and we insert inside this vector database the embeddings object. Running this command right here. Now we are able to test our vector database. with this little command here. When we invoke similarity search, this function here takes the question and converts it into a vector, into a numerical representation, and then perform the mathematical search into the vector base. So because we put here this value as 3, this function is going to return the top 3 most relevant results that are going to answer our question. So just that we see right here. The top 3 results are plant-based vegan question, because we are looking for vegan food. And the second one is the botanic, and the last one is the botanic table as well. Now, let's set up Langfuse for observability. Langfuse is like a dashboard for your agent that helps you see what's happening inside, what question is getting, how it's thinking about them, and what answer is given. To use Langfuse, you will need to create an account and get your API keys. First, you need to set up at the langfuse.com page, but if you already have an account, you can use an existing account. Then, you need to create a new organization and project, and then you need to copy your public keys and secret key and host URL. Once you have your credential, you can go and configure Langfuse in your code. I already did that. Let me show you my dashboard. This is my dashboard. I don't have nothing yet because I just created. Once you have your credentials, you can configure Langfuse in your code. I already set up my credential here in my environment, so I don't going to run this cell, but I'm going to run this one. Okay. So this client will allow us to send traces and evaluation results to Langfuse, giving us visibility into our agent operation. So this is the agent. And now we need to create a restaurant recommendation agent. For that, we are going to use the Strands Agent framework, of course, and we are going to use the Anthropic model. So remember to put your key in this environment on this code. This agent will use our vector database to provide restaurant recommendations based on user queries. First, we will create a search custom tool that the agent can use to query our vector database. So we are going to use the same code that we use to test the vector database, but here we put some description, and of course we use the tools decorator. And then we need to create the agent itself. When we create the agent, we place the trace attribute and metadata to trace for filtering and analysis. The agent is going to use this search tool to find relevant restaurant information and generate helpful response. The trace attribute parameter is important for observability because this is going to add the metadata that we are going to search on the Langfuse dashboard. Because this is a demo, the metadata is the same almost always, because I'm going to have a unique user ID, and I'm going to generate a unique session ID using a random number, and I put these tags because you can search on the dashboard using tags as well. Now we can test our agent with a simple query. We are going to use the same query that we used to test the vector database. After running the agent, we can review the traces in Langfuse. So this is the dashboard. We have 10 traces here. I did some more traces that you see in the video. You can see the model cost. You can see the model usage and trace by time. You can see the user consumption. This is the user ID that I'm using right now, and remember that I put this in the code. the trace latency, the generation latency. We have a lot of information here, and model latency as well. So you can see each trace here in Tracy. I run this demo before and I received some error here, and then I received the right response. Let me show you one of the right response here. So you can see the question here, the assisting response. We can see the loop that the agent execute to answer the question. So I will help you find restaurant with good vegetarian option. Let me search for that information. We can use the tools ID. So this is a lot of information about our agent. Here we can see the three response that the vector database give it to the agent to create the answer that the agent give us. This is our first demo. Let's return to the Jupyter Notebook. Now, let's use Ragas to evaluate the quality of our agent response. Ragas Retrieval Argument Generation Assessment is a framework for evaluating RAG Retrieval Argument Generation System. Ragas help us measure how well our agent is performing by looking at different aspects of this response. Is the agent information accurate? It is relevant to the user question? It is using the right tools? Is the agent communicating in a friendly way? To start with Ragas, we need to set up a large language model for Ragas evaluation. To do so, you need a model to be set as the evaluator. Ragas allows you to use any model as evaluator. Here, we are going to use the same model that we use in the agent. So we are going to use an Anthropic model. Then, we need to define a Ragas metric. Ragas provide a suite of agentic metrics designed to evaluate the conversational and decision-making capabilities of the AI agents. In our AI agent workflow, we need to check two things. One, if the agent finished the task and if it meets important business goals. These goals include making customers happy, finding chances to sell more products, or keeping the company style of the communication. To help with this bigger evaluation needs, the Ragas framework lets users create their own ways to measure success. Two examples for these flexible measurement tools are the Expert Critic metric and the Rubber Score metrics. The aspect criterion metric is a simple yes or no evaluation tool that checks if an agent's response meets a specific rule that the user creates. These rules can be about any good behavior we want from the agent, like giving other actions, following ethical rules, or showing understanding and care. So let me show you this in the code. We create some adversarial rules. For example, we have here the brand voice metric with a definition that returns 1 if the agent's communication is friendly, approachable, helpful, clear, and concise. Otherwise, return 0. And then we have the rubric score metric that lets you create a scoring system. A set of different scores, each with an explanation of what it means, and then uses an AI model to decide which score best matches how good the response is or what qualities it has. Let's see. We set up 3 scores for this metric. First, we have -1 for cases where the customer asks for something not on the menu and the agent doesn't suggest anything else. 0 for cases where either the customer asks for something that is on the menu or the conversation is not about food or menu items. And we have one for cases where the customer asks for something not on the menu and the agent thus suggests something else. With this scoring system, we give a negative number for wrong action, a positive number for right action, and 0 for cases where this evaluation doesn't matter. And finally, we define metrics to evaluate the RAG, retrieval augmented generation aspects for our agent. When an AI agent uses external knowledge to answer questions, we need to check how well the RAG system works. RAG helps the agent give correct, useful, and fact-based answers. The Ragas framework provides special tools to measure how good Raga systems are. These tools check two things: how well the system finds the right documentation and how good it uses that information to create answers. This checking is very important because if the system doesn't find good information or uses wrong, the agent may give false or confusing answers, even if the response sounds good. In our example, we are going to use the context relevance metric to measure how well the retriever context addresses the user's query and the response groundedness to determine the extent to which each claim in the response is directly supported or grounded in the provided context. So let's come back to the code. So here I define the RAG metrics. We have the context relevance and the response groundedness, and they are using the evaluator LLM to get the results. Now that we have defined our evaluation metrics, let's create some helper functions to help us processing the trace and send the results back to the Langfuse. So this is the code that we are going to use. Then I will set some support evaluation function for the Ragas framework. Then evaluation results can be saved to CSV, and we can see this result in the Langfuse console as well. And finally, this code right here creates the main function that gets the traces from Langfuse, processes them, run Ragas evaluation, and pushes a score back to the Langfuse. I know, there is a lot of code here. So I don't want to bother you with the explanation because I want you to see the results. Please take your time to review this function. It's only code. So let's run the evaluation code. I'm going to start the video here because this takes a few minutes. The evaluation is over and we can see this result in the notebook right here. Everything is at 0, so according to our rubrics, the model always responds well. We can also go to the Langfuse dashboard and see the result here. So we have 14 trays, and here we can see all the aspect criteria metric that we define in the Jupyter notebook. And we have all the 14 trays with the value 0. As you can see, this is a very basic example, but you can add complexity with more tools and more complex prompts for the agents. This approach provides a comprehensive framework for building, monitoring, and evaluating AI agents by implementing observability and evaluation. With this, you can debug issues more effectively. You can measure and improve your agent's performance over time. You can ensure your agent meets quality standards, and you can know what's happened when a user interacts with your agent. And thank you for joining us in this journey to get it started with Strands Agents. And we hope you will apply this concept to your own projects.